Before I start into what is Tanzu Kubernetes operations, I kind of wanted to set some, context and a little bit derived from the conversations that we already had today. I think there were certain questions like, how do I get a developer environment set up? How do I even have access to that Kubernetes API, or how is TAP layered over there? And things like that. So I'm hoping that this particular segment will help answer some of those questions. Now, we all know, and we've seen these with customers in various environments and various scenarios where sometimes we have customers who have, either by choice, they have made a decision of going hybrid or multi-cloud, where they're running workloads on vSphere, as well as they want to move certain of their workloads into a cloud provider or into a cloud environment. Or sometimes customers, that there are line of businesses and there are teams that are actually going out and creating a Kubernetes environment or using a cloud API that they want to. If you think about the application development teams, right, the reason why they're looking at Kubernetes as going into these different cloud providers or even utilizing Kubernetes is that it provides them a single API versus for them to understand a lot of these things, right? If I'm a developer and I don't care about my infrastructure, I just want to, start deploying applications, or I just want to have this code that, gets deployed by Tanzu application service to a Kubernetes runtime. It doesn't really matter to me. But if I'm talking to Kubernetes as such, that Kubernetes platform tends to be that singular API that translates all of those requirements from that application perspective, whether it's coming through directly the Kubernetes API, whether it's coming through something like Knative, whether it's coming through something like Tanzu application service, doesn't really matter. As ultimately, those abstractions are getting deconstructed by Kubernetes to these different cloud provider environments, right? And what in return happens is as Kubernetes, starts deploying different application objects, it's essentially creating a lot of these different building blocks, or utilizing a lot of these different building blocks within those cloud provider environments to manage those containerized applications, manage microservices, manage a lot of the things that are needed for those containerized applications to stay in place. And also, application development teams, operations teams, they are very wide teams, wide words, right? You could have a team that does everything from writing code to pushing it to Kubernetes to setting up that Kubernetes environment, etc. Or there are teams that are separate. Depending upon the organization, you could have different teams doing different roles and different, objectives. But when I talk about application development teams, these are the people who are writing code, who don't really care about where that runtime is coming from. All they really care about is, how can I push my code to that runtime? So as a result of that, as teams, start throwing either kubectl, here's my application, here's my requirements, go run it. Kubernetes is going to start deploying those applications, builds microservices, build the requiring or underground storage requirements, config maps, etc., needed for that application to stand up. And it's also going to start constructing those backend, building blocks, or molding those building blocks, or starting to build something within those cloud provider environments to, curate a lot of this, or to orchestrate a lot of this. Now, the team who is deploying these applications, their concern is really the security and supply chain around how can I take my code and put it to production. Now, a lot of times as we go through these motions, right, there's an assumption that the underlying API that is governing the infrastructure, or that is managing or orchestrating the infrastructure, tends to be Kubernetes. And that tends to be our, kind of default go-to platform as we talk a lot about these things. Now, the reason why Kubernetes is popular is, of course, people love that API. It's a singular API. It runs across multiple cloud providers. You get portability, etc. But managing as a team that layer of Kubernetes APIs, or maintaining Kubernetes, securing it, is a completely different challenge in itself. And that is what I think we're going to talk next, is kind of take a look at somebody who is responsible for maintaining that platform, right? Maintaining the Kubernetes layer on top of a cloud provider, or multiple cloud providers for that matter. And the team that's coming in and pushing applications, whether through Tanzu application platform or directly talking to Kubernetes API, doesn't really care about managing and maintaining that. So let's walk through a little bit of what are some of the challenges the team who's actually maintaining that runtime faces, right? So if you look at day zero, now the reason why Kubernetes is able to talk to all these different cloud providers is because it has plugins that work across all these different environments. So if you say, Kubernetes, give me something, I need an application provision, I need storage for that application. It's that same API, but Kubernetes understands how to translate that to AWS, to vSphere, to Azure, to Google Cloud, right? But and that's the beauty of it. But imagine if you have to actually, take the CNCF landscape and push everything that is required to create that API so that it does a lot of those things, that's quite a task in itself. So the ability to provision a Kubernetes cluster that's kind of cookie cutter style or reproducible in whether it's on-prem or it's on cloud, that's key. And even if sometimes, customers may not be using or may not actually, run or have the necessary need to, build a cloud provider or build a Kubernetes cluster, they could be leveraging a service like GKE or EKS. Even then, maintaining those environments can take some time. Right now, let's say the platform operator has actually built that API, and they want to now provision this to, or they want to provide that API back to the application development teams. Like, here is your cluster, here is an environment, here's what you can do with it. That API is pretty powerful, and the person who has access to that API can essentially go ahead, do a lot of things in your infrastructure. It can start building, storage volumes that are 1 terabytes, or you never know what kind of bill you're going to get next, right? So passing that Kubernetes, and Kubernetes by default doesn't have those constructs of identity management or user management, who is authenticated. It has constructs around roles and RBAC and stuff like that, but it doesn't really, it cannot just, bring in identity coming in from your Active Directory services and authenticate a user around that. So how do you provision or how do you provide that API to the right teams across those different platforms that are deployed across maybe multiple cloud providers? So that's kind of how do I, day one, if I have the API, how do I even know who is the right team to give and what level do I need to give them to? And then we talked a little bit about during, Aaron and Ryan's presentation around securing the supply chain, right? And we showed like how there are different ways of securing, whether, there are CVEs and kind of the containers or the base images that we are using, leveraging, etc. But there's a wider set of kind of, maybe enterprise-wide requirements around security that could be kind of, package applied across even beyond the supply chain, right? For example, there are enterprises that do not want development teams to start deploying applications from Docker Hub, for example, or any other public registry. They kind of have requirements that I just need this particular public registry or my own container registry to provision workloads. And so something like that. So kind of establishing how these, there are some guardrails that are enterprise-wide that may not necessarily apply as a pipeline or as a security or as a supply chain, but these are kind of wide levels of topics or areas that you want to think about, like infrastructure quotas, right? How much can somebody deploy? How much consumption can be created, etc. So thinking about how do you apply those policies on a day-to-day basis. And then as these microservices get deployed across a lot of these scenarios, kind of figuring out like, are we exposing anything that's not necessarily needed? Is the database being exposed? Are communications encrypted by default? Who is managing security? Who is managing the certificates, management, rotation, etc. about these microservices? And, kind of can we build certain monitoring capabilities that we can see all these services, what's happening, amongst themselves. So this is kind of what I feel like is, a day-to-day life, somebody who's leveraging or who is maintaining that Kubernetes platform, whether it's on a cloud provider or it's on-prem. And then, usually when you're running software, something or the other is always going to go wrong. And so when it comes to troubleshooting, can I get access to a full stack metrics? Can I see what's going on all the way from application to infrastructure? And, can I root cause effectively when a problem arises? So that is what a challenge is on a day-to-day basis. And with Tanzu for Kubernetes Operations, we are hoping to solve a lot of these day-to-day issues that a platform team that is running or creating that, managing that Kubernetes runtime. Now, how we are doing that, I think Tanzu for Kubernetes Operations, we are hoping it to be an integrated solution that, picks on a lot of existing technologies that VMware has, but giving an integrated experience. So you'll see that on day 0, we are leveraging Tanzu Kubernetes Grid, which is a way of establishing or creating that runtime on a cloud provider or infrastructure of your choice. So it gives you the ability to set the right kind of, base operating images to the drivers needed to run a cluster effectively, to, high availability of that cluster requirements, etc., taken care of. On day 1, we used Tanzu Mission Control, which is a way to deliver that Kubernetes API to the dev teams in a self-service pattern. So providing that self-service way of getting teams that API and providing them the right access is what we'll see how Tanzu Mission Control is going to help us. And again, Tanzu Mission Control is also going to help us define those kind of broad level policies around what is possible in terms of what container services can we download, what registries are allowed, what network policies we define, etc. And then, of course, the supply chains can define a little bit more granularity or add more granular concepts over there. And then finally, we have Tanzu Service Mesh, which provides, default mutual TLS. You can see a lot of the monitoring capabilities, what are the services, what are the microservices that are running, what kind of traffic I'm getting, what is, the time taken for an application to reach that traffic, etc. And then we have Tanzu Observability, which is going to look at a full stack metrics. It can take logs, it can take time slice metrics, from all the way from Kubernetes layer to the infrastructure layer to the application layer.
Yeah, I'm looking at this. It looks like Tanzu is for enterprises who want to build their own cloud as a kind of abstraction layer over the top of existing clouds.
The story is really about how enterprises want to, Kubernetes is essentially providing that, right? Portability into, okay, I have an application, I want the ability to run it anywhere, and Kubernetes kind of provides those abstractions itself. The story here is really about, wherever you're running that Kubernetes runtime, whether it's on a cloud provider, even if you're using existing services from that cloud provider, how are you going to manage the entire life cycle, the day-to-day operations for that runtime? That's what the product is about.
Yeah, so I guess where I'm not quite clear on, we've touched on a few elements of it, I think, today, of how much of it do I need to construct and build myself, and how much of it comes out of the box when I buy it from VMware. That's where I'm not quite sure about.
Yeah, now I'm just going to getting into demo mode, and maybe that might help, but sure. A lot of this is, we have SaaS services that enable you to kind of look at everything together in one place. But at the same time, because we are talking about on-prem environments as well as cloud environments, we do have certain components that you can go and install if you have a cloud, if you have an on-prem environment, if you have an edge use case where you don't necessarily, you want a Kubernetes runtime, and you probably have other areas where you want to kind of look at things in a uniform fashion, because a lot of times you don't see a singular Kubernetes cluster coming up, right? You might see multiple of them coming up. And just the way Kubernetes is constructed is you don't see a lot of the visibility into these things, or even managing. So one thing is visibility and one thing is managing it. There is no way of kind of singularly seeing everything what's happening. And maybe I don't know if I'm helping here, but probably my demo might help a bit better. I'm getting into a little bit of some of the component pieces where I started. Like you can see, this is Tanzu Mission Control, where you have a lot of clusters that either you provision through Tanzu Kubernetes Grid on an on-prem environment. So if you see, I have a vSphere cluster running here, which I provision using an on-prem, TKG, Tanzu for Kubernetes Grid tool. But at the same time, I have a GKE cluster that I just brought into this environment, which may be, a line of a business ops person created, and they just want it to be managed by us or by the central IT team or whatever you want to call them, right? And you'll see, like, we have certain clusters that we created in AWS, in Microsoft Azure, and some of them we attach directly. So you can see this is an EKS cluster that is not, deployed by us, but if somebody has already created that and this is a brownfield environment, you're actually able to bring that together. Now I could, this is kind of my, this is my single viewpoint, right? And I have all the other components that I spoke about in my slide kind of integrated with this particular portal over here that you're seeing. So like I mentioned in day 0, I could go ahead and create a cluster. I have Tanzu Kubernetes Grid runtime created or enabled for my environment in AWS. I could have that enabled for vSphere. I can pick that environment. This has all the backend infrastructure requirements, authentication details pre-created when I ran that Tanzu Kubernetes Grid runtime over there. And then I can go ahead and create that cluster. What this is going to do is it's going to go into that AWS environment. It's going to start leveraging, bringing up some EC2 instances, creating elastic load balancing services to build that Kubernetes API, right? So this is day 0. It is already automated. All I have to do is provide my credentials within that AWS environment, kind of set a little bit of what kind of, so for example, if I actually click through some of this, I can actually call it a name, give it to a cluster group, and I can define what's my, region, what's my, and then these options would be different for different cloud providers. So because this is an AWS provider, you'll see a region coming in here. But if this was vSphere, it could be, something completely different that vSphere needs. If I click next, I can talk about how much, what's the sizing for my cluster. This is what the EC2 sizing would be equivalent to when it starts deploying the cluster, etc. And I can go click next, tell the number of worker nodes, etc. that I need in, and then click on create cluster, and we'll start provisioning cluster within the AWS environment. Of course, I don't have access, and that's one of the beauties of this is I can set access to what capabilities I can do. But I have some pre-provisioned clusters that I already did create using this environment. And that is create a cluster. I could even attach a cluster. So if I have a GKE cluster, I can bring it together just to get a sense of what's going on. Now, let's say, I do have that API, and how do I provision or how do I provide that API to my app dev teams? So I get into policies and assignments, and you'll see that, I have a group of clusters like default, etc. And, I have a bunch of clusters within these cluster groups. I can actually go into a policy engine that can define what level of access I want a particular user or a group to be. And this identity is coming, it's already, so if you're part of VMware Cloud Services, you've already, created your own or brought your own LDAP Active Directory servers, users, and this is where that identity and services are coming from. So I can just add my email ID and bring that in. So this is how, when I log in let's say if I'm a developer and I log into the same portal, I will have the access to all the clusters in this cluster group, whether they are in on-prem, whether in a different cloud provider, for this particular set of rights within the Kubernetes API. So that's how, as an ops person, I'm able to give you that level of access that's right. And I also don't have to, talk to anybody. Like as I go into my cluster that I'm, allowed to kind of look at, I can get into actions, access this cluster, and download the kubeconfig file. So this is how, let's say if I'm a developer and I'm trying to use Tanzu application service to deploy my application, this is how I would get that kubeconfig file in my local terminal environment. Now that is one set of policies. Again, like I mentioned, we have, there are multiple different set of things that you could do. For example, you can apply, policies around image registry, what kind of image registry is, allowed. You can even create a allow list, white label everything that is allowed, and everything that's not listed here will not be allowed to deploy any containers. So if I say, I don't want any, particular, any Docker Hub images, I could just say, anything from Docker Hub to not allow here. I can, define a host main dockerhub.com, and none of those containers from that particular site would be able to install. Similarly, I have network policies that I could apply. Again, you could deploy it at the org level where it can trickle down into every cluster that is being managed, or you can define it at very specific cluster groups. I can also define certain broader security policies around what kind of containers can be deployed, in the sense that whether they have root access, no root access, etc., and define quota and custom policies. So if none of these policies work for you, you can even define your own custom policies for a particular group of clusters or a single cluster. Doesn't really matter. So this was about, how do you get those kind of broader level policies determined from an enterprise perspective. And then on day two, let's say this is the cluster that we are working with, there's an issue, something goes wrong, and there's a ticket like, traffic is not flowing in, or something with that application is not right. I actually have direct integrations with this cluster into Tanzu Observability. I can click on that, and I see all the metrics coming in for this cluster into this portal, like, how many nodes I have. And this particular view that you're seeing is also customizable. I can add as many metrics I want. I can create different views as I like, etc. So this is already integrated within Tanzu Mission Control and Tanzu Observability. Now, this is a cluster level metric. I can also get into applications and look at kind of what are the different app metrics that are flowing in. So as people start, creating their code and start utilizing those supply chains, they can actually plug metrics that can flow here as well. And so you get a singular stack view of what's going on from an application perspective as well. Now, going back again, like, let's say now I want to take a look at what are the microservices getting deployed, what's happening there. Again, it's a single button click into Tanzu Service Mesh. I can even onboard that cluster with a single button click. Here are the different application services, that are deployed in that cluster. I can take a look at what's going on, what's the time that it takes for a service to reach certain place. I can even, look at the performance, etc. I can take a look at what is being exposed from my environment in those different microservices. And I can use a concept called global namespace to kind of look at, broader cross-cluster, cross-cloud services, microservices that were created. And all these services by default, you'll notice, will have mutual TLS enabled. There's no need to do automated certificate management or any of that.